Hey guys, welcome back. We're going to start off this new unit talking about polynomial and quadratic functions by focusing on adding polynomials together. So a couple of things I want to show you first, then I'm going to dive into some of the problems I expect you to finish. So first off, when we're talking about these polynomials, it has, it's basically a function that has a lot of little pieces together. And each of those little pieces have different exponents or degrees. To illustrate that, to try to make it click by looking at visuals, what most mathematicians do is they make it look like either a square, just a rectangle, or a little constant one. Now, if we were in So by thinking of it this way, you can more easily combine your like terms together. For example, if I had a bunch of x squares, like let's say I had 3 x squares, I could take 3 of these x squared tiles to represent that. 3 x squared. If I wanted 2 x's, okay, I could take 2 of these x tiles and put them together. If I wanted 5 ones, 5 constants, I wanted a plus 5. Okay, 1, 2, 3, 4, and 5. You see where that's coming from? And then I could do the same thing if I had negative tile or negative numbers. So let's say I wanted negative 2 x squared. Okay, there's our negative 2. Minus an x minus 1. So I could use these tiles to represent these different polynomials. When you are adding polynomials together, all you have to do is simply combine the like terms. And that's another reason why we use these tiles to illustrate that, because it's easier to tell which terms are alike. When we see it for the first time just as a function, as an equation, sometimes it's a little tricky because those x's, the variables, throw us off. But if you see their visual representation, you could easily tell, okay, these would combine together. These x squares would combine together. These x's would combine together. And these constants would combine together. Now, when we combine these together, if you see a positive and a negative, then those cancel each other out. Positive and a negative cancel each other out. Positive and a negative cancel each other out. Positive and a negative cancel each other out. So the only thing you'll have left over is the stuff not canceled out. So in this problem, the only thing left over is 1x squared plus 1x plus 4. Keep that in mind. Let me show you some of the activity you're going to be working on. This is the more standard look of our tiles. They're color-coded, so to speak. And instead of them all being blue positive, the x squares are blue and positive, the x's are green and positive, and our constants are yellow and positive. All I want you to do is combine the like terms, because really that's all adding is just combining like terms. So let's put the like terms together. Let's see, I have x squares, 2, 3x squared. I have my 2 x's. I have 1, 2, 3, 4 constants. Anything behind me? Nope. So combining my like terms. Now, I could use that and write my polynomial in standard form. Now, standard form is actually not as tricky as you might think. All you have to do is just put the biggest exponent term first and work your way down to the constant. So for this problem, I want 1, 2, 3. I want 3x squared plus 2x plus 1, 2, 3, 4 plus 4. You see where that's coming from, guys? My x squares, I combine them together. That makes a positive 3. My x's are next. I have 2 of them, so that makes a positive 2x. My constants, I have 4 of them, so that makes a positive 4. Now, if we throw negatives into the mix, just like what we saw with those tiles before, it's okay. It's not that big of a difference. Let's put our x squares first. So that's 1, 2, 3. And then I have one red negative x squared. Let's put our x tiles together first. There's 1, 2. Anybody? Then let's put our negative x's together. 1, 2. And then last, let's get our constants together. There's 1, 2, and then our negative constants. 1, 2, and 3. Combining those and writing that in standard form. Keep it in mind that our positive and negative cancels each other out. So actually, I might be able to do this easy. On the activity, I could cross out one of each. So there's one red, one blue crossed out. Here's another positive versus negative crossed out. Here's another positive versus negative crossed out. And then let's take care of our x tiles as well. Positive, negative, positive. Oh, wow, that got rid of all of them. So we're not going to have any x term at all. But let's write down what we have left over. I have 2x squared. And then I have 0 x's. Whenever you have 0 of something, you don't have to write it down. Last, on my constants, I have just a minus 1. So I have 2x squared minus 1. And that's adding polynomials by just combining like terms. Thanks so much, guys. We'll keep in touch.